Let's consider an inclined plate, on which a jet of water is impinging. Here, as the plate is inclined, three forces comes into the picture. The force along the direction normal to the plate, force along the x direction, and force along the y direction. In general, force exerted by a jet on a plate is the rate of change of momentum, along the direction of the force. Hence, force exerted along any direction x is equal to the initial momentum of fluid, minus final momentum, divided by time. As we all know, momentum is the mass times the velocity. If you take the common terms, mass and time, out, it becomes mass flow rate. Let's start with the force along the direction n. We know the initial velocity of the jet along the direction x is v. But, now we need the initial velocity along the direction n. If the plate is inclined at theta degrees, its component along the direction n is v sine theta. As the water doesn't flow along the direction n after striking the plate, the final velocity along the direction n is 0. Hence, the force acting on the direction n is rho a v squared sine theta. Now, the force acting along the direction n is known. Also, the angle between the normal and the x direction is 90 degrees minus theta. The component of Fn along the direction x is Fn cos 90 minus theta. We know that cos 90 minus theta is sine theta. Hence, the force acting on the direction x is rho a v squared sine squared theta. Similarly, the component of Fn along the direction y is Fn sine 90 minus theta. We know that sine 90 minus theta is cos theta. Hence, the force acting on the direction y is rho a v squared sine theta cos theta. Thank you. Don't forget to subscribe.